Okay, and we are now recording. So this is, as I said, part 2 of what's on the forest floor and why exactly. So we're going to get into some different things from last week's presentation, but still about the same thing. And again, all of this information, almost all of it, was provided by Dr. Todd Smith, who is a research ecologist with the U.S. Forest Service. Very intelligent man. Now, the first thing I wanted to bring up is that this is a 1900 map that was produced by the USDA, and this shows in the dark green everywhere in the United States in 1900 where wheat and oats were being produced. In other words, the agricultural usage of the land throughout the U.S. And as you can see, the entirety of Ohio, as I have circled here in red, is completely covered in green. And that is what happened when Ohio was settled in the 1830s and 1840s. Just about every bit of land was stripped and or drained for farming. The wooded areas were pretty much all stripped except for areas in the Hocking Hills, and almost all of the wetlands were drained and filled in for agriculture. As I have mentioned before, an early historian had said that at the time the first settlers came to Ohio, it was so heavily wooded that a squirrel on the banks of the Ohio River could travel from the banks of the Ohio River to what at the time was the Indiana line without ever touching the ground. And that quickly changed as all of the forests were cut down. Something like 93% of all the forest land was cut down, and I believe it was 90% of all of the wetlands were drained and filled, and this was all done for agriculture. And that's what you see here in the green. In 1900, this was the state of the state. And this next map, which is also a USDA map, Linda's wanting in. Okay, we'll let her in. This next map, which is also a USDA map, this shows the percent of cropland across the United States. We fast forwarded here in 1997. And if you see there in Ohio, the eastern half of the state, or western half of the state, excuse me, pretty much all dark green, which means 75% or more was prime farmland. 47.1% of that was a total of prime farmland that was in 20.6% of the total watersheds. And in the lighter green, you can see is the eastern half of Ohio, and that's 50 to 75% of that land was farmed on 37.4% of the total watersheds, and 24.5% of it was on the total watersheds. So still pretty much all of the state, except for the very bottom southeast, was, you know, and you know, again, this is generalization. It doesn't take into account cities. Still very heavily farmed. And again, the heaviest of it in the West. And, you know, keep in mind, this is this heaviest area. This is the area that was the heaviest impact by our ice age, which ended, if I remember right, 14,000 years ago. The area most heavily impacted by the 3 glaciers that came through here. That's what made all that land on that western part of the state, and even through our area here, so very flat, and so very productive for agriculture. And now, surprise, fast forward to 2018, here's a U.S. Forestry Service map that shows land usage. And if you see all that green, that's all deciduous forest. The forests are actually rebounding. The forests are coming back. There's a lot of land that in the east, as you can see all this green, there's a lot of lands, and even in the a little bit down here in the southwest corner, that farmers are no longer farming and are returning, actually, as I've indicated here with the red arrow, to deciduous forest. The forests are coming back. And these, where's my cursor? Here it is. These states down in the southeast and the very bottom south that you see where the counties are highlighted in dark black, those are ones that have significantly come back. And you wonder how it is this happens. I have a good explanation for you that I found out about, and I'm going to share that right now. Anybody have any questions before I go on to that? Okay, good. Linda, are you in? I know she was trying to get in. Okay. It is something called succession. And this is a graphic depiction of what succession is. And this is an example actually that I took from a very interesting web page from the Duke University education website about Duke forestry environments. And this is an example from North Carolina Piedmont region, which is very typical there. And from left to right, when land is left undisturbed, land that used to be farmland in this case, the first year, it is what is called horseweed dominant. The land gets taken over by crabgrasses and pigweeds. The second year is what is called asters dominant. Crabgrass is the main thing that is dominant on the land. And then the third through the 18th years, it is called grass scrub community. And it is mostly broom sedge grass and some young pines and junipers start to develop in that stage. And then in the 19th to 30th years, it starts to become young pine forest. They start to grow up in there. Those become the first of the pioneer trees. And in the 30th to the 70th years, it becomes a mature pine forest with the understory of young hardwoods, young deciduous trees. And then little by little, a transition begins to happen. In the 70th to 100th years, pine transitions to deciduous, to hardwoods. And then from the 100th year on, it's called a climax, and it turns into this oak hickory forest with the kind of understory that we're going to be talking about in a few minutes. So this is called succession, and this is what is happened. This is what happens in the wild when it's unaided. And I have my own little story to tell about this, actually. When I was still living in New Jersey, on my way to work every day, in South Brunswick, at the intersections of Route 1 and Henderson Road, there was a British Petroleum BP gas station, and it closed down and the building was removed, but the concrete pad that it was on remained. And I noticed and was interested in the fact that, you know, over time, some low weeds grew up around that pad, and crabgrass and so on grew up in the cracks in between. And over time, these little bushy plants and what was probably, you know, multiflora rose, you know, sticker bushes grew up around the pad and in the cracks. And, you know, if I had been involved in nature then like I am now, I probably would have stopped and taken a photo every 6 months, because over the 30 years that I passed that every day, little by little, that concrete got swallowed up by plants, and you know, they're pretty much became an understory there, and small trees grew up, and by the time I left there, that corner where that gas station had been was pretty much a pioneer woodlot with some, you know, some pine trees that were probably 12 to 15 feet tall, and some hardwood saplings in there, and a pretty good understory of a variety of plants that I know now were both native and invasive, and it was very thick, and you would have never known that there had been a concrete pad from a gas station there. You know, and the last I had actually seen of the concrete, it was all broken up and was being swallowed up by the plants, and that was the beginning of succession there at that corner. So very, very interesting. And I wish I would have known about things like this and would have, you know, taken a series of photos there, because it's, to think back on it now, is very interesting. So we're going to switch gears a little bit here. This guy, our Ohio State mammal. Well, a lot of people, we've got people in the waiting room. Okay, Carolyn and Linda both, I've got to admit them. We'll pause here for a minute. Carolyn's connecting. Linda's trying to connect. Anybody have any questions so far while we're waiting here?
I feel bad for Linda because she couldn't connect last week either. Said she was going to go to get her phone fixed or something.
Yeah.
Evening.
Hello, Carolyn. Good evening.
Oh,
Yeah, Linda's not connected, but has tried. I've attempted to let her in again. How are you, Carolyn?
doing good, thank you.
Good. You jumped in at a perfect time. We are just about ready to
Oh,
talk
good.
smack about our Ohio State mammal.
I was just running a little bit late because my okra molded where I was trying to hang it. I had to divide it, pull the molded out.
Oh, okay.
It shows Linda on the list. I think she's in.
Are you there, Linda?
No.
It doesn't say mic off. It just shows video grayed out.
Yeah, it does show her on the list. Okay, we're going to continue here. Again, our Ohio State mammal, they call them wood rats. Some people call them corn rats, farmers do, and it's for a good reason. These guys, when they go unchecked, are very bad for our forests, and you will see why. Number one, there's a number of plants they don't eat.
Oh,
They don't eat these. The hay-scented fern, May-apples. They do not eat May-apples. They hate May-apples. They do not eat the black cohosh, which there is a lot of them typically in our forests. And in some forests, there's a whole lot of May-apple also. They don't eat those. The New York fern, which is usually very abundant, they don't eat. They don't eat white snake root. As my mom and dad have discovered, they do not eat jack in the pulpit. They don't like those either. And I think, as we've talked about before, jack in the pulpit are very, very unusual and interesting plants because they grow both a female and male part on one stalk. And the female part actually, and that's what you see there in the foreground on that photo, they trap insects. So they are both carnivorous and they also photosynthesize. They do both, which is very unusual. So it makes them very interesting plants to botanists. There's only a couple of plants that do that. And then they, again, another abundant one, they do not like to eat Pennsylvania sedge, which is very abundant. They do not like, although they like to hide in them and lay in them, they do not like to eat prairie grasses. And although we mentioned a couple in specific, they do not like to eat most wild ferns. So that's a bunch of different plants they don't like to eat. And you'll see in a few moments, this is important. However, they do love these plants. The bellwort. They love to eat those, and they will eat them like crazy. The zigzag goldenrod, which is different from the goldenrod that we see bloom in the fall in such great quantities. They love to eat those. They love both the false Solomon's seal, which has those dainty little white flowers at the top of the stems, and the true Solomon's seal, which look very different. They have the droopy pod-shaped flowers, not at the ends of the stems, but towards the ends of the stems. They love bloodroot.
It's poisonous.
Which, yeah, poisonous to us, but not poisonous to them. They love bloodroot. And as Christy had talked about in her wildflowers presentation, even though bloodroot is poisonous, some of the Native American tribes used bloodroot to ingest. They actually ingested it to induce vomiting, among other medicinal uses.
Interesting.
Yeah. And then on the right, the wood nettle. They love wood nettles. They love to eat the jewel weed, which is also something that is very prominent in our forests. And they also happen to love our state flower.
No.
The large white trillium, or is also known the great white trillium. The scientific community prefers great white trillium, but we all know them as the large white trillium. The deer love those also. Now, all of these plant species, they will, anywhere that they find them, they will eat them down to the ground, actually right down to the ground until there are no more. They will go into the area and eat all of these plant species right down to the little nubs, down to the ground until there are no more. And this is a big problem, a very big problem, and I will explain why. If deer populations go into a certain area and do that, and they are unchecked, meaning the deer populations are not controlled by some means, either through controlled hunting or through keeping them out of an area, a forested area, by deer fencing, for example, that helps invasives spread. Because if you've got an area where the understory is mostly those what are called palatable species to them away, then that makes a lot of room for the invasives to very quickly move in. And it also can help a very quick and very thick spread of the unpalatable species, those ones that they don't like. And doing that diminishes, either one of those things diminishes the plant diversity, which causes that low floristic quality index that we talked about in part 1. And that's, it's unhealthy for the forest floor. You need the plant diversity so that it helps with the equal spread of nutrients to the soil, and it helps keep the soil from being depleted of any of the nutrients, because different plants, use different nutrients more than others. It helps keep that balance. And it also, when this happens, can for a time accelerate something called the fuel loading effect. Anyone heard of that before? Fuel loading?
No.
Fuel loading is something that is part of what is called forest degradation. And forest degradation, which is what the deer do when they eat all of those palatable species out of a section of forest, they degrade the forest understory and they create something called fuel loading. And what they do, what this means is they have set the stage for forest fires. So I have 3 points in this photo here. Point number 1, they have eaten away a large portion of the understory that was there for number 1. So you've got a lot less ground cover there. Number 2, they have exposed a lot of the dead leaves that are there from like the prior years, that are, the dead leaves, the detritus, the pieces of dead twigs and sticks and old tree bark and things like that are on the ground. Once all those cover plants are gone, that stuff's exposed to the air and will very quickly dry out. So that stuff, it's exposed to the air, it dries out. It is now, since it's dried out and exposed, that is very, very available fuel in great quantities. Okay, that makes sense?
Yeah.
And at number 3, you've got your sunlight that comes through, because you do have some coming through. Even if you've got a good canopy cover, you still have sunlight coming through. And what's doing? It's getting to that fuel along with your air. And with our climate changes, with like here lately with your unseasonably warm days, and you've got all these dry, now exposed, dried out leaves and pieces of bark and twigs and stuff on the ground. You get unseasonably warm days, and all that sun shining through and you get wind, you've got the perfect mix for forest fires. And they're happening because the deers have eaten away all this ground cover, and there has not been a chance yet for either the unpalatable species of plants or the invasives to grow in and cover over that stuff. So in doing that, the deer are setting the stage for forest fires. They are degrading the forests. They are creating what is called fuel loading. And I got this information from it's very technical, but it's a very informative PDF titled "Degraded Forests Are More Susceptible to Forest Fires: Some Possible Ecological Explanations." And it's from the Journal of Science and Technology, actually published by the government of Ghana, because they did research into this. And you know, they have much more to deal with in terms of forest fires there than we do, because they're in a much warmer on average climate than we are, much hotter climate. Does that make sense to everybody? Any questions on that? So the deer aren't doing us any favors when they've, you know, when their populations go unchecked and when they are not controlled going into certain forest areas. And this is, you know, highly evident in the spring when they go into certain areas and they eat every wildflower they see. They eat all the blooming wildflower plants because they have a big tendency to do that. You know, I know they've always had a problem with this if anybody ever goes to the Stratford Center up at Preservation Parks in Delaware. They've got that nice forest there, and they've got this one very large area. It's like, I don't know, 25 or 30 acres that in the spring for a certain period, the whole thing at once blooms with the spring beauties, just absolutely covered with spring beauties. But after they've been up for a day or so, the deer move in, and in the course of one night, they will eat all of the spring beauties, all of them, right down to the ground in the course of one night. And that's exactly the kind of thing that will cause the forest degradation. Now, on the other side of this, there is benefit for the forests for fire when it is in the form of prescribed burns. And now Christy and Glenna and I can tell you about the benefits of prescribed burns that are done at the metro parks and the grasslands. And it's the same thing when it is done in the forests. The prescribed burns have quite a few benefits. The first thing they do, obviously, is they take out invasive species and they kind of reset the clock, if you will, bring everything back to the starting gate, if you will. There are actually quite a few non-invasive native plant species for which fire actually aids germination of the plant seeds, believe it or not. There are some that even fire accelerates germination of the plant seeds, and they're dependent on it. So that's a very big benefit. It also, the burning of the plant matter, actually that ash helps to reset or regulate, if you will, the pH of the soil. And of course, when that burning happens, there are quite a few arthropods that, you know, get killed, burned in the process, and that adds nitrogen back into the soil, which is a good thing. So there's, you know, quite a few different benefits to this. And, you know, when it's done in a controlled method, like is shown here, and, you know, only the understory is burned, and you don't lose trees in the process, it is beneficial to the trees because, you know, they are getting that extra pH re-regulation and the extra nitrogen and so on in the soil. When you have your next few rains, they benefit from that. Now, anybody have any questions on that before we go on?
No.
Okay, now we're going to talk about something here. People probably don't know about it. I know I didn't. Called the Vinton Furnace Experimental Forest. The Vinton Furnace Experimental Forest, and I'm going to do this because I need to pull up some information on this. Because I do, sorry about that. You can still see this, right?
Mm-hmm.
Because I do not have this memorized. Oops. The Vinton Furnace Experimental Forest, that's in southeastern Ohio. It is a 1,585 acre forest that's been a dedicated research area since 1952 by the U.S. Forestry Service. And since 1965, it has been dedicated to sustainability research. It's mainly a hardwood forest, and it is, believe it or not, one of the most diverse plant ecosystems in the country. And these two slides, I'm going to pop this back up full again. This one slide, can everybody see this now?
Mm-hmm.
Again, I'm going to go back to what going on here. There we go. Now this shows, whoops, I didn't want to do that. This one shows a comparison of information between the 1950s and the 2000s for that forest. And this is just the bottom line data from all of their plant inventorying that they did. In the 1950s, their inventorying, they found 536 taxa, meaning different species, which included 95 different families of plants, 300 and 14 genera of plants, and of all the species in there, 92% were native. And then in the 2000s, and I don't know the exact year, the number of species, the taxa had jumped to 673. So jumped up by about 150. And the families had jumped up some from 95 to 105. The genera a little bit from 314 to 336. But then the native had dropped a little bit from 92 to 88. So it had gotten overall more healthy. And, you know, this was an area that was untouched and, you know, intentionally untouched. It was an area that, you know, just was not widely open to the public, and not a lot was done to it. And they were very careful to, you know, with it, to make sure that, you know, it just to make sure that it was unaffected. Let me put it that way. And they also did some inventorying based on the areas, because there are different areas within this forest. It's pretty varied. And they found by habitat in dry woods and woods, edges of woods, 39 different plant species that were native there. In acidic woods, they found 5 species. In rich woods, meaning mostly moist woods and ravines, 5. In bottomlands, 6. So a total native species of 55. And 55 species also were common in the 1950s. So that did not change over time. But those 55 species are now elsewhere outside of Vinton Furnace, are either uncommon or rare. So there's 55 species within Vinton Furnace Experimental Forest that are common there and were common there in the 1950s, that were common throughout Ohio in the 1950s, but are now uncommon or rare outside of Vinton Furnace today, but are still common within Vinton Furnace today. That makes sense?
Mm-hmm.
So that's, I find that very interesting. This is a, you know, it's a very well protected and looked after piece of property. And so it's very interesting that you've got that many species there that were all over the state, and now they're only there, or mostly only there. They're not thriving around the state anymore. So does anybody have any questions on any of this at this point? The one thing I will say, Christy and I haven't talked about it yet. I'm not sure whether we're going to do her presentation, her program for next week, or whether we're going to do my thing next week. But when we get to, whenever it is, when we get to my next presentation, it also relates to this, and it is another two-parter. It is entitled More About Fungi, and it relates very closely to what happens and what goes on the forest floor. And I think you're going to be surprised by a lot of it. There is a lot that we didn't cover in my first program about mushrooms, that is in this program. And I think you're going to be surprised by a bunch of things. There is a lot going on with fungi on the forest floor, that just, it's going to surprise you. I think there's going to be a lot that you were not aware of, and there's going to be things that are really going to be interesting and surprising. There's going to be some things that just, I think, are going to bowl you over about it, and I won't say any more than that, but it really is very closely related to what we have talked about this week and last week. So hopefully you will look forward to that. Any questions or any comments on any of this? Anything anybody'd like to talk about related to any of this forest floor stuff?
This is great, Dawn. Are you going to go into, along with the fungi, about the breakdown, what their role is in breaking down the forest floor and contributing to the nutrition of the soil? And
Yes. Yeah.
I feel like you should probably go ahead and continue those parts. Leave me off for a bit. I may be going to Florida, probably going for the launch on the 14th, and there's an awful lot going on here right now.
Okay. Yes, we can absolutely do that. Again, the More About Fungi is a two-parter, and it's definitely going to be a full 2 hours. There's a lot to it. There's a lot to it. I'll say that.
Sounds interesting.
It is. It's, coming from it's coming from a class that I sat in on via online video, and I just was amazed at how much I learned about it. And this was a few weeks ago, and I learned just so much that I didn't know about it. And I, ended up telling myself, I have to do a program about this. I have to share this information. This is something I think, a lot of people are going to want to know about. So yeah, it is, if it's as interesting to me as it was, I think it'll be interesting to you folks as well.
Great.
Okay, and I'm going to stop the recording at this point.